Eccentricity is the tendency not to follow a predictable path, or a nice path, if you will. Let me see if I can get you an example. Got it. Try this. Negative x squared plus 4x plus y minus 3 equals 0. Good.
I'm sorry, I'm not.
Nate, on the other side, please.
I wasn't talking, I'm just shielding myself.
This is called preventative measures. Thank you. I picked you at random, by the way. Could easily have been 2 other people. Keys and points. What I'd like to do is find the eccentricity. We could usually just use E for eccentricity. I'm a little nervous about using E for eccentricity because that's actually a number. E is 2.71. But in this book, they do use E for eccentricity. So what is it? How do you find eccentricity? What's the very first thing you have to decide? What's the first thing you have to figure out? Good. What shape it is. What shape is this? It's a parabola. How do you know that so fast?
It's just x squared.
Yeah. One variable is squared and one variable is not. This thing has to be a parabola. Does that make sense visually? How do you find eccentricity of a parabola? Good.
Just one.
It's 1. Every parabola on Earth has an eccentricity of 1. Your problem's done. If you get a parabola on this worksheet, rejoice and be glad, because your work is done. Let's try another one. This one's going to be a little sneakier. I know, actually. Negative 4x squared. Find the eccentricity. Go. Why do you say that?
It's a circle.
How do you know it's a circle?
There's both x and y are squared and have the same coefficient.
If x and y are both squared and they have the same coefficient, positive or negative, I don't care. I mean, they both have to be positive or both have to be negative. They have to be identical. This thing's a circle. Let me prove it to you. Divide everything by negative 1. Bless you. Actually, divide everything by negative 4. You're going to get some fractions. It's okay. It's going to be x squared plus negative 3/4 x plus 3y, sorry, plus 2x plus y squared equals whatever that is, 74 over 4, which is 37 over 2. The rest of it is a mess, but look at these. It's a lot more obvious. This thing is a circle. And every single circle on Earth has an eccentricity of 0. If you have a circle, rejoice and be glad. Not quite as easy as a parabola, because you can just say, oh, 1 squared, 1's not. Boom, eccentricity of 1. Done with the problem. Here you might actually have to look kind of hard. If both variables are squared and both have identical coefficients, that thing is a circle. The only exceptions we have not even run into yet. Questions so far? Let me try this. Come on, you weasel. You wait. Yes. Oh, this thing. Example. 16x squared. Plus y squared minus 160x plus 3d4 equals 0. I'm going to clear this out. Hopefully that wasn't too bad. First of all, what shape is it? Can it be a circle? Can it be a parabola? Why not? Yeah, both variables are squared, so it cannot be a parabola. Parabola is one variable squared and one's not. Can it be a circle? No, why not? I'm sorry, say again? Right, the x squared and the y squared have different coefficients. That means they're going to be different radii sizes. So it cannot be a circle. We now have ellipse or a hyperbola. Can it be a hyperbola? Katie? What makes a hyperbola hyperbola? What do we change in the formula? It's almost identical to an ellipse formula, but there's one difference. Josh, go. Subtraction. It's either x squared minus y squared or y squared minus x squared. One is positive, one's negative for the squares. That would be a hyperbola. This is not. Does that make sense? If this were negative 16x squared plus y squared, or if it were 16x squared minus y squared, hyperbola. Well, what does this thing have to be now? It has to be an ellipse. Here's the first time we actually have to work for our bacon. I want to know the eccentricity. Can somebody give me the formula for the eccentricity, other than a parabola or an ellipse or a circle, which are easy? C over A, correct. What does C stand for, Sam? Focal move. In an ellipse, what does A stand for, Austin? In the hyperbola, yes.
So, well, it's like the radius, but it's like, I can't remember exactly what reading, so it's like.
How do you tell the difference between it?
Between like A and B, like the larger one is A.
Yes, the major radius is A. So this is the focal move over the major radius, if you're looking at an ellipse, which we are. I do not know what the focal move is, and I do not know what the major radius is. Other than that, we're doing great. Any ideas what to do? Oh, math people. If I told you to graph and analyze this thing, what would you have to do? Okay. Get it in the right form. How? What technique? Go. Double complete the square. Right. Let's put the x's together and the y's together. Go ahead and read them off. What are the x's? Yep. Good. Plus blank, and then try the y column. Nothing. Yeah. Put 0 y and then plus blank. What should I put here? Right. This is the leftover number here. Get it over on the other side because it really doesn't help us much. Yeah. There's our start. What's the next step in this double complete the square stuff? Merrick, take over. Try this. What would you do first? Definitely. 16 and then parentheses what? Yep. Plus blank. How about this one? Yeah, this stays put. You could pull a 1 out of it. It makes you have a better day. There's really nothing to pull out. Becca, take over. What would you do now? Okay. Oh. Yeah, condense it or compress it to a what sort of thinking? Square the first. A binomial squared. Which one did it come from? Good, because it's square the first, and this is double the product. So what should have been here? 25. That's extra weight we didn't have. So, is this right? Right, it's 16 times bigger than we thought it was. 16 times 25, anybody know what that is? It's up here. Do it on paper if you need to. 400. Now try this one. Josh, what binomial squared did this thing come from?
Let's just do y plus
0. And what should have been here? 0 times 1, I suppose. You add nothing. So, Katie, take over. What's over here right now? What's negative 34 plus 400? 16. Good. Now we're getting close, but if it's an ellipse, what is the answer after equal? 1. How do you get it down to 1? I'd love to, but then you'd have a minus 15 on this side. That's legit, but there's one other way.
Oh,
Divide by 16, as long as you do it to both sides. That means divide everything by 16. Reduce this for me. Yeah, x minus 5 squared over what? 1 plus. Would anybody forgive me if I did y minus 0? It's the same thing. No, I insist on plus 0. Minus 0 is offensive. No, that's equals what? Yeah. Does that make sense? That's necessary work. Not that we're necessarily going to graph and analyze it, although we might. In the final version, like what you'll have on the test, there are not going to be all that many problems on the test because they have multiple parts. I might just give you a formula like this, and say graph and analyze. And from this point on, include eccentricity in your analysis. So you're just taking to have one more element. By the time you're done with the other stuff, the eccentricity is pretty easy. You'll have C already, you'll have A already. So you just slam them in to be done. Here, we're doing all this extra work, and it looks like, oh my goodness, we have to do this with every single problem? Yeah, but you'll have done it already. So, how do you find, can you tell me anything about this thing? And analysis-wise? Megan, take over. What does A stand for again? Like in an ellipse? You can look here a little bit. This is the horizontal radius squared. And this is the vertical radius squared. Which one is A? In an ellipse, they don't have a leader. It's go.
it's the major radius.
Whichever one's bigger. So it's the major radius. In this case, what would it be?
16.
Sort of. It's already squared though. 4. A is radical 16, which is 4. That's the bigger one. Then the horizontal one is, how big is B in this case? It has to be radical 1 or 1. That make sense? So A happens to be the vertical radius, and B happens to be the horizontal radius. So if you wanted to graph it, that's how you do it. Where's the center on this, by the way? We don't need it, but 5 comes 0. So you'd start graphing it, 5 comes 0. How do you find C? Nate, take over. In an ellipse, what's the formula for C? A squared minus B squared, radical, correct. Radical A squared minus B squared. How do you know it's minus and not plus? How do you tell? Because one of them is plus, one of them is minus. How do you know which one's which? This is correct. This is an ellipse formula.
The small one would be minus the small one that wasn't that negative.
Right, that's true. A has to come first. Why is it A squared minus B squared and not A squared plus B squared? Because one of the formulas is A squared plus B squared.
Because it's an ellipse. It's a hyperbola, it's A squared plus B squared.
Correct. If the original formula has a plus, the focal move has a minus. If the original formula has a minus, the focal move has a plus. So remember those two. I wish they matched. I wish the plus went with plus and minus went with minus. They don't. It's kind of sad. But can Nate calculate this for me? If A is 4 and B is 1, go for it. What's A squared? 16 minus 6, 1, which is, so radical 15. Focal move is radical 15. Tell me what the eccentricity is.
So it's about
4. Now you're done with the problem. Does that make sense? So you have to do the work that you normally would have done with analysis. Again, on the test, this is actually going to be easier because you'll have done that already. You'll have done all the hard work of getting in the right form, graphing, analyzing. You'll have horizontal, vertical radius. You'll have foci, blah, blah, blah. And then at the very end, you'll include eccentricity, which is just one extra step. It'll take like 10 extra seconds. And that's if you're reading carefully, which you should. Questions? You do the exact same thing for a hyperbola, put it in the correct form, just one little catch, 2 little catches. What's the formula for the focal move for a hyperbola? Austin?
A squared plus B squared.
Radical A squared plus B squared. And what does A stand for in a hyperbola? Anybody? Yeah.
Leader.
The leader radius. Right. It's not necessarily the biggest one. It's the leader radius. Questions so far? All right. Pray for the photocopier because the last time I sent something down there, there were more red lights on the bloody machine than I've ever seen in my life. Somebody tried to send a fax to the thing, which I didn't even know those things existed anymore. But theoretically, I'll be back in 45 seconds. 45 to 60 seconds. Okay.
Definitely not. Definitely not.
Yeah.
Sorry, do you guys know how to get to Sister Mary Daniel's classroom? Or is this it?
The store. Yeah.
Sorry, can I get through that?
Yeah, yeah.
Okay. I don't know where I'm going. Can you tell?
Next door or the street? Yeah, you can straight through that. I'll be the door.
Take one.
Yeah, right.
It's 2 right. So you're right.
Good work.
Dang it.
We should beat it up.
Yeah. Yeah, I can just hear the remorse in everybody. Wow. That didn't take long. Just, hang on a second. Oh, come on, you little psychedelic. Got it. And we're gonna get a lot of exercise today. Okay, that is all I have for now. The assignment, I'll just put it up here. It's called 6D-2. Let me take a look here. There are 12 problems. I'm only assigning 1 through 6. No, I take that back. 1 through 8. The last 4 are a little more tricky. I'm going to hold those off. I just sent it to the downstairs printer, so I'm going to be coming back up wheezing and gasping and out of breath. I'll be right back. You know, this is probably the most boring thing of the people who are on at home. Sorry, y'all. I'm just gonna call it quits for now for the video. God bless you. Keep you, stay healthy, etc. And there's the assignment, where my finger's pointing right there. And I'll email it to you if necessary. See you later. Bye-bye.